is given the next information. This question asks you to investigate some properties of the sequence of functions of the form fn of x is cosine of n are cosine of x is greater or equal than -1 and less or equal than 1, and n is positive integer. Important: when sketching graphs in this question, you are not required to find the coordinates of any axis-intercepts or the coordinates of any stationary points unless requested. A. On the same set of axes, sketch the graphs of y is f1 of x and y is f3 of x for x is greater or equal than -1 and less or equal than 1, 2 marks. f1 of x is just cosine of 1 arc cosine, so it's just x, and this graph is just a straight line. And f3 of x is cosine of 3 multiplied by arc cos of x. And using a calculator, we know x is in between -1 and 1, and since it's cosine, its range is in between -1 and 1, so we choose x to be from -1 to 1, y also to be from -1 to 1, and we get the next. For cosine of 3 arc cosine x, it looks like this, and we need just sketch it. And y is x, it's just a straight line, so it's f1 of x, it's f3 of x, from -1 to 1 for x, from -1 to 1 for y. B. For odd values of n is greater than 2, use your graphic display calculator to systematically vary the value of n. Can suggest an expression for odd values of n, describing in terms of n the number of local maximum points and local minimum points, 4 marks. Actually, since we have considered f3, so when n is 3, we can see that there is 1 minimum point and 1 maximum point. And let's consider n to be 5 and n to be 7 to understand the pattern for odd values of n. So when n is 5, we can see that there are 2 minimum and 2 maximum points. 2 minimum, 2 maximum points, and let's consider n to be 7, and we can see 1, 2, 3 minimum points and 3 maximum points. 3 minimum and 3 maximum, and we can suggest the general formulas, and we can see that it's n minus 1 over 2, the number of local maximum points. Local maximum points. So 7 minus 1 over 2 is 3, 5 minus 1 over 2 is 2, 3 minus 1 over 2 it's 1. And since the number of local minimum points is the same, so it will be the same. N minus 1 over 2 is the number of local minimum points. The next, on a new set of axes, sketch the graphs of y is f2 of x and y is f4 of x for x is greater or equal than -1 and less or equal than 1, 2 marks. So let's consider n to be equal to 2, and it looks like this. And when n is 4, it looks like this. and let's sketch it. It should be symmetrical, something like this. So it's f2 of x, f4 of x, from negative 1 to 1 for x, from negative 1 to 1 for y. D for even values of n is greater than 2, use a graphic display calculator to systematically vary the values of n, hence suggest an expression for even values of n describing in terms of n the number of local maximum points and local minimum points for max. So n is 4, and we can see that there are 2 minimum points and 1 maximum point. And let's consider n to be equal to 6 and n to be equal to 8 to understand the pattern. So n is 6, it looks like this. And we can see 1, 2, 3 minimum and 2 maximum. 0.3 minimum to maximum, and when n is 8, we can see that there are 4 minimum and 3 maximum, 4 minimum and 3 maximum, and we can suggest the next general formulas. We can see that for maximum it can be described as n over 2 minus 1, 8 over 2 minus 1 3 is 3, 6 over 2 minus 1 is 2, 4 over 2 minus 1 is 1, so it's correct. It's a number of local maximum points, and we can see that for minimum it's just a half, so it can be described as n over 2, a number of local minimum points. The next E, solve the equation fn derivative of x is 0, and hence show that the stationary points on the graph of y is fn of x occur at x is cosine of k pi over n, where k is a positive integer and k is greater than 0 and less than n for marks. So we should consider the derivative fn of x, it's cosine of n arc cos of x, and derivative. Since it's a function of more complicated argument, we should apply a chain rule, and it says that derivative becomes cosine derivative, it's negative sine, and keep the same argument, so it's negative sine n multiplied by arc cos of x, and multiplied by argument derivative and arc cosine derivative, and it's constant, and arc cos derivative formula is given in a data booklet, and it's -1 divided by square root of 1 minus x squared, and it should be equal to 0, and we can see that it can be equal to 0 when sine of n arc cos x is 0, but 1 minus x squared cannot be equal to 0, so x cannot be equal to plus minus 1. And let's consider in general cosine and arc cosine. Arc cosine as inverse function of cosine. So to get a graph of arc cosine, we consider part of cosine. It must be one-to-one function, so that the inverse to exist, and we consider from 0 to pi a part of cosine, and if we need the inverse, y becomes x, x becomes y, and the graph of our course looks like this. So x changes, and for cosine y values changes from -1 to 1. So for arc course as inverse function, x changes from -1, x values change from -1 to 1, and y values change from 0 to pi. And we can see that sine is equal to 0 from a unit circle. We know that sine is equal to 0. Argument is pi k. K in general is any integer. So an arc course is pi k. In general, k is any integer, but since n is positive integer, arc course is also positive. And we can say that arc course, the range for arc course is strictly greater than 0 and strictly less than pi, because x cannot be plus or minus 1, so endpoints must be excluded. So n arc cosine is positive, so pi k also must be positive. So k is positive integer. And arc course, it's pi k over n, and then applying cosine on both sides. Cosine of arc cosine is just x, is cosine pi k over n. But we can see that cosine is from 0 to pi, so k is a positive integer, and also since cosine is from 0 to pi, k is should be greater than 0 and less than n. Endpoints are excluded because x cannot be plus or minus 1, which are endpoints. So we get the result as required. The next, the sequence of functions f(n) of x defined above can be expressed as a sequence of polynomials of degree n, f. Use an appropriate trigonometric identity to show that f2 of x is 2x squared minus 1, 2 marks. What is f2 of x? It's cosine of 2 arc cos of x. And definitely, to get rid of cosine and arc cosine, it must be cosine of arc cosine, because cos is inverse function and they cancel each other and we get just x. So we can see that it's cosine of 2 arc cosine, and we can apply double angle formula. It is given in the data booklet, and it says that cosine of 2 theta is 2 cosine squared theta minus 1. So we can rewrite it as 2 cosine squared, but only over just arc cos of x, and minus 1, and cosine of arc cosine is just x. So it becomes, but it's squared, so it will be x squared, so it becomes 2x squared minus 1 as required. Consider fn plus 1 of x, which is cosine of n plus 1 arc cos of x. G. Use an appropriate trigonometric identity to show that fn plus 1 of x is cosine of n arc cosine multiplied by cosine of arc cosine minus sine of n arccosine multiplied by sine of arccosine, 2 marks. It looks like sine or cosine of some difference, and hence we can see that we can just rewrite it as cosine of n arccos x plus arccos x, and consider it as a cosine over sum, and using the formula from a data booklet, it's cosine of a plus minus b is cosine a cosine b minus plus sine a sine b. So it becomes cosine cosine, so it becomes cosine of n arccos x multiplied by cosine of arccos x minus sine sine, so it's sine of n arccos of x and multiplied by sine of arccos of x. And let's check. Cosine of n arccosine, cosine of arccosine minus sine n arccosine multiply sine arccosine. Correct. And the next H shows that f n plus 1 f n plus 1 of x plus fn minus 1 of x is 2x fn of x and is positive integer, and express f3 of x as cubic polynomial, 5 marks. So we can consider similarly fn plus 1 we have obtained fn plus 1, so we need fn minus 1. So fn minus 1 of x, it will be n minus 1 minus will be here, so it will be a cosine of the difference, so it will be absolutely the same, but there will be plus, so it will be absolutely the same, but here will be plus. So let's just rewrite, so it will be cosine of n arc cos x multiplied by cosine of arc cos x plus sine of n arc cos of x multiplied by sine of arc cos of x. And we need to consider fn plus 1 plus fn minus 1, so it becomes fn plus 1 of x plus fn minus 1 of x is, so we can see plus minus, this part cancels, so it becomes 2 cosine of n arc cosine x multiplied by cosine of arc cosine, but it's x, so we can write that it's 2x cosine of n arc cos x. And cosine of n arc cosine, it's our general formula, it's fn of x, so we get 2x fn of x as required. And the next part, express f3 of x. What is f3? f3 of x, it's cosine of 3 arc cos of x as a cubic polynomial. It is not indicated directly that we should use the previous result, but definitely we should use it. So if we need f3 of x, we can, using this identity, we can write the next, that fn plus 1, it becomes f4 of x plus fn minus 1, it's f2 of x, is 2x f3 of x. So we need what? f2 of x and f4 of x. f2 of x, it's from the previous part, it's this one. We can see that it's 2x squared minus 1. So from f2 of x is 2x squared minus 1. So we need to find f4 of x. What is f4 of x? It's cosine of 4 arccos of x, and definitely it's we need cosine over arccosine actually, so they can cancel each other. And similarly to f2 of x, we can use double angle formula, and the formula says that cosine of 2 theta, it's 2 cosine squared theta minus 1, so it becomes 2 cosine squared, but of 2 arccos x minus 1. But what is the cosine of 2 arccosine? It's actually f2 of x, because n is 2, so it's 2, and this cosine is 2x squared minus 1, but it must be squared and minus 1. And let's expand it, it becomes 2 4x to the power of 4 minus 4x squared plus 1 minus 1, and it becomes 8x to the power of 4 minus 8x squared plus 1. And now let's substitute our results into this identity. So f4 of x, it's 8x to the power of 4 minus 8x squared plus 1 plus f2, which is 2x squared minus 1, is 2x f3 of x. And we can see that it becomes 8x to the power of 4 minus 6x squared is 2x f3 of x, and finally f3 of x is, just divide each term by 2x, and we get 4x cubed minus 3x. And that's all for this question.